Welcome to the Lab 2 Safety Information and Lab Setup. The next lab you will be completing is called the Identification of an Unknown Solid and Liquid Using Physical Properties. Physical properties are the properties of a substance that can be measured without changing the identity of that substance. Every substance has different chemical and physical properties, and these properties can be used to identify that substance. You'll be working with a partner today to complete this lab. While you and your partner are sharing unknowns and supplies, each member of your group should record quantitative and qualitative data in their own lab notebooks and turn in individual lab reports. Next part of this video is all about lab safety. Today we will be using solvents that are flammable. We'll be using cyclohexane, it says flammable right there on the bottle, and methanol, also flammable. Flammable substances have a tendency to light on fire more easily when they are near an open flame. So we will not be using Bunsen burners to heat our water today. We'll be using hot plates. If you're a smoker or you light candles on a regular basis, make sure you wash your hands very thoroughly before leaving lab today. In addition to two of our solvents being flammable, some of the unknown liquids themselves are flammable too. They say so right on the bottle. So be extra careful. Because the unknown solids and unknown liquids are unknown, you do not know what the substances are. So you don't know what properties these substances have. Be very careful not to get any unknown solid or unknown liquid onto your hands, because it may be harmful to your skin. If you accidentally get unknowns onto your skin, run your skin underwater until you have washed all the chemicals away. Whenever chemicals are being used in the lab, make sure you wear your safety goggles. Even if you are finished, someone else might be carrying chemicals and you don't want an accident to happen. The next part of our video is the lab setup of Part 1. Part 1 is the solubility of your unknown liquid and unknown solid. We'll be determining the solubility of our unknowns using test tubes. And test tubes are best stored in a test tube rack. You can find test tube racks on the shelves on the side of the lab room or underneath the lab cart. Because you will have many test tubes, you should carefully label them using labeling tape and a marker or pen. Because when you get 10 test tubes into a test tube rack, they tend to all look the same. Once you have added your unknown and the solvent, you're going to need to shake this test tube to determine if the substance is soluble or not. Do not put your finger on the end of the test tube and shake it up, because this will get solutions or substances on your fingers, and it may be harmful to your skin. You have two options. You can use the black corks that are on the lab cart to shake it this way to see if your substances dissolve or not. Or you can leave the test tube uncorked and just shake it gently, trying not to splash the liquid out of the test tube. The next part of this lab is the setup of the boiling point of your unknown liquid. You will not need to determine the boiling point of your unknown solid because solids do not boil. For this part of the experiment, you will need a ring stand. Ring stands are found on the side of the lab room, on the shelves, and they are used to hold clamps which hold our glassware above the lab bench. You can find test tube clamps, like this one, in the drawers on the side of your lab bench. Make sure you put them back there at the end of the lab. You can load the clamp by putting it on the top of the ring stand and tightening it down. Into the test tube rack, you're going to put a large test tube. Not the small ones. You'll be determining the boiling point of your unknown liquid using the large test tubes. Into your large test tube, you should put a boiling stone. Boiling stones are little plastic stones that promote even boiling, and it's where the bubbles will form in your unknown liquid. So you'll put a boiling stone in first, then you'll add about an inch of your unknown liquid for boiling purposes. Since you need to determine the temperature of the boiling, you will need a thermometer out of your lab drawer. Measures in degrees Celsius. Make sure you use the correct number of significant figures. You'll then need a ventilated cork to hold the thermometer in the test tube above the level of the liquid. If your thermometer falls through, you can use a little rubber band at the top of the thermometer to hold it in the cork. We need to heat the unknown liquid, and today we're going to make a hot water bath using a hot plate. This is a hot plate. It works very much like a stove. It has a knob on it to turn it on. And you can find the hot plates on the side of the lab bench, on the shelves, like you did the ring stands. You'll then need a beaker of water since you're going to be boiling this water. And I'm using a 400 milliliter beaker filled with water. You can just use tap water. You do not need to use... Not enough space. You do not need to use deionized water. You can use tap water. So you'll put the beaker of water on the hot plate. Turn on your hot plate about the middle of the line, and lower your test tube down into the water. You want all of the liquid inside your test tube to be covered by the water in the beaker. You will then carefully monitor the temperature as it goes up and make observations about what is happening to the liquid inside your test tube. When the bubbles are forming a constant stream, that is the boiling point of your unknown liquid, and you can record the temperature in your lab notebook. After your liquid boils, move the test tube clamp out of the water so the liquid stops boiling. The next part of the experiment is determining the melting point of the unknown solid. You will not be determining the melting point of your unknown liquid because it is already melted. You will still need a ring stand and the hot plate and a beaker of water. Move the hot beaker of water off of the Bunsen burner using one of these hot pads. Pour the water out into the sink and get a fresh beaker of water because you want to start with cold water when you're boiling. You will still need a ring clamp, but instead of putting a test tube in, we're going to be putting a cork directly into the ring stand, into the test tube clamp. So I have my ring stand, my test tube clamp, beaker of water ready to go, hot plate still off because I'm not ready to heat it yet. We'll be measuring the melting point of our unknown solid by putting the solid into a capillary tube. It's a little bitty tube, looks like this. It has a closed end on one side and an opened end on the other. Before you can put solid into the capillary tube, you first need to put a little bit of solid into a watch glass. You could then use a scoop to crush it into little pieces so that it will fit in the capillary tube. To get this unknown solid into the capillary tube, scoop a little bit of the solid up in the capillary tube and tap it down on the lab bench. Be careful, the capillary tubes are fragile. Scoop a little bit more, tap down, scoop and tap until you have 6 to 8 millimeters of solid. Not quite 1 centimeter. Because we are measuring the melting point, we need a thermometer. I have a thermometer and a ventilated cork ready to go. And I'm going to use another rubber band to hold the capillary tube to the thermometer. Okay. So now I can put the capillary tube attached to the thermometer into the test tube clamp. And then I will lower the thermometer and my unknown solid into the beaker. I can then turn on the hot plate. The water will heat up from the hot plate, which will increase the temperature of the solid until it melts. You're going to want to keep a close eye on the unknown solid. It will start white, and once they melt, they turn clear. Make a note of the temperature change as that happens in your laboratory notebook. At this point in the experiment, you have finished all 3 parts. And if you're happy with your data, you can stop. If you have time, you can repeat any of the 3 parts that you would like to get additional data. Before you leave, it's important to clean up, and we start cleanup by putting our lab waste into the designated containers in the fume hood. I've taken one of the containers out of the fume hood to show you an example of what it looks like. This is the waste container we will be using for this particular lab. Because some of the substances are flammable, it says flammable right on the container. And it is labeled hazardous waste. This is our class, 140, and the lab is unknown substance. You'll notice that the cap is on the bottle. Whenever you come over to the fume hood to put unknown or waste into the bottle, take the cap off, put a funnel in, pour your waste into the bottle, tap the funnel to get any excess waste off, put the funnel down on the paper towel, put the cap back on, and walk away from the fume hood. You should never leave a container open in the fume hood if there is a cap. So we're going to put our unknown liquid, any extra solvents, our unknown solid, all into this container. Just one container for this lab. You can then wash things out in the sink, and you can pour the water from your hot beaker down the drain into the sink also. The capillary tubes should not go into the hazardous waste. Instead, there will be a beaker labeled waste in the fume hood for you to put the capillary tubes. After you've put away your waste, you need to clean up your lab bench. You will put the ring stand and the test tube clamps, things that you borrowed from the side of the room, back. Put things back in the cart, clean all of your glassware, put it into your lab drawer, lock your drawer, wash your hands, and you are ready to go.